So hello everyone, it's nice to see so many participants from both Lithuania and Latvia markets. It's a pleasure to know that the topics we organize and prepare for you are relevant for both markets today. And hopefully you will find the information useful and suitable for your own business. So today main speaker is our friend and partner Alexander from Bexel. As usual, we're gonna have questions at the end, and I think we can begin. Yeah, Alexander.
Yes, thank you very much, Rolandas. First, to introduce myself, my name is Alexander Ilic. I'm a senior BIM manager and product specialist at Bexel. So I'm more or less involved in development of Bexel Manager and Bexel CD solutions, and also working as a consultant on the projects. Today, I'm going to try to introduce you to Bexel Manager workflows. Webinar will be combination of presenting the use case of large-scale project where all the Bexel workflows were involved, as well as part of a live demonstration of some of the concepts in order to bring it closer to the audience. At the beginning, just a few words about our company. So we are present in 75 countries worldwide, 16 years in construction management, 20 years in software development, with estimated over 700 plus billion US dollars of project values managed by our software solutions, with over 8,500 projects managed by our software solutions, of course, of diverse projects types and sizes. So we are present in many countries around the world. Many different companies are trusting us, and we are trying to improve our solutions and to bring the new quality to construction industry. Today, I'm going to talk. I'm going to try to present the whole workflow throughout the case study of National Football Stadium in Belgrade, Serbia. It's a large-scale project which with very tight schedule, because the simply the time slots are very narrow, because it is intended to be built in the next 2 years. So you're gonna see what we were able to achieve with implementation of BIM on this project, and which practically wouldn't be possible actually with traditional approach. So just a few information about the project itself. So the construction period, as you see, is roughly a little bit more than 2 years. The investor is public ministry, of course. General contractor is Power China Construction Corporation. A lead architect is Fenwick Iribar and Architects, and structural designer as well-known companies in designing the stadiums. So it's a huge project, as you can see, by the number of seats, by the number of square meters that will be built, and as I said, it has very tight schedule. So the first thing and the first issue that we actually had is how to first, in a very quick period of time, establish the construction, establish the workflows, establish the rules, and how to actually set up everything for the start of construction. So the first step was, as always, BIM execution plan. So the first thing we did, we simply lay out the very detailed workflow, how every participant on the project will actually use BIM, and how they're gonna, what are their intended workflows, what they have to do on the project, and how they need to simply comply to the rules of the project. And of course, well, we also had to go through the integrated workflows throughout the complete project execution. So from the 3D visualization to the quantities dashboards, integrated environment, schedule analysis dashboards, look ahead plans, progress inputs, BCF workflows and document approvals, and project management reporting. So all of that was something that had to be addressed in all of these PEP documents, and that has to be done. And the first thing that happened is that we received the model in the stage it was in the early conceptual stage. And what the investor wanted is early on a quick and efficient analysis what we can achieve and how it could be achieved. So from the early stage of the project, we had to know exactly what are the resources needed, what is the time needed for the execution. So we had to more or less go through the study of this project feasibility, let's say, in a very short period of time. So what we did is we simply implemented integrated BIM and the full power of integrated BIM in order to achieve this. So what we basically had is like 2 weeks period of time just to come up with the schedule, quantities, like the resource graphs and everything that will give investor a picture what needs to be invested in which order in order to achieve this very ambitious goal. So I mean, I'm going to go from the beginning to the end from the practical point of view. So the first thing that we had to do is we had to organize the model that we received. And this is the struggle that, I mean, probably all of you already have. So the first thing is you get the model that is done by the designers. It is completely natural that designers simply don't have in mind technology of execution. They simply don't have in mind the way the building is going to be built and all the struggles that you're going to have on the construction site. So the first thing was optimal location-based model structure. That means that we had to take the model as it is, and in very short period of time, to simply organize it and to change it in order to fit the sequence of execution that is needed. I mean, some practical examples, you get the stadium with the slab, one slab for one floor for the whole project. So you can imagine how it would look like if you try to schedule or to track the progress on a stadium like elements of such scale that are going to be built in reality for like 6 months altogether to simply complete one slab. So the first thing we had to do is, because we didn't have control of the original model, we had to split model elements into smaller pieces to create the logical zones or tacts in order to achieve, simply to make the model useful for the construction sequence planning in the future. So for this, what we did, we used our mesh splitting workflow. That means that when we integrate IFC models that we received from the designers, we were able to simply specify in one simple input format to specify actually how we want to split these model elements, and we did it in a most logical way. So we split it into zones and subzones that were more or less equal in size in order to, in the future, optimize the sequence of execution. That means to use more or less the same amount of resources throughout the project execution. So that was the first step. And in this specific case, it more or less took us like 1 day to do it. Even though it's a huge project, it was a huge model. With this advanced algorithm, we were able to simply do that in more or less 1 working day. So the next challenge is okay, now we have the model split in the proper zoning, but what we need to have is to simply specify for every element in which spatial zone it is. So because again, the designer simply didn't even have the idea or the information how the building is going to be built in which sections. So there was a second challenge here, and that was how we're going to be able to simply easily identify which elements are placed in which area of the building. And here we took advantage of our advanced clash detection engine, which contains containment clash, which could identify elements within spaces, within bigger elements. So what we had to do, we simply run the clash detection and simply clashed the spaces of the model, so the rooms of the model, with the elements in the model. So namely, okay, furniture is less important than, let's say, equipment and finishes and MEP lines. And what we did, the system automatically identified, let's say, that the pump number 001 was in the machine room 04 on the level 6, and we had ability to automatically add this information to the model element. So the hundreds of thousands of model elements in a very short period of time, in a half a day or day, and to have very clear information about where certain elements are placed within our building, so that our sequence in the future will reflect the spatial structure of the model. After that, of course, we use quantity takeoff and CBS, or custom breakdowns creations, to visualize all of this data enrichment. So to visualize if we properly populated the zones for the building, if we properly arrange the levels. So if we don't have elements that are assigned to the second level and they're actually on the fourth level, and we also use advanced algorithms to auto distribute those elements to make it be on the proper side. And what we did then, after we did the location properly, we actually started developing location-based scheduling. What this means? This means that we were able to simply use, I'm going to later maybe go more in detail in a live part of a demo how this system works, but we were able to build the location part of the scheduling within Bexel Manager. So to build schedule from the model itself, because we simply now know for every model element in which zone it is, on which level it is, in which subzone it is. So we were able to simply specify the sequence, logical sequence of execution for these zones, and to more or less build the schedule structure within the model. So from the model to the schedule, and not in traditional way to simply put the schedule without having the model in mind and without having the actual spatial structure of the building in mind, and then trying to somehow map that structure of the schedule with the model itself. So in this case, the model was built, or the schedule was built from ground up. Then the next step was, okay, we did the location part. So we actually located all the model elements within functional zones that will be the board structure of our schedule. The next step was the functional structure of our schedule, or let's say methodology or sequence of execution. So we had to simply specify in which way this building is going to be built. And here we again, we were lucky that we have a lot of experience with the stadium. So this is not the first stadium we built. So we already have a predefined structure or methodology structure for the stadium buildings of this type. So what we reused the knowledge from before. So we simply imported one standard schedule methodology for the stadium, repurposed it and customized it a little bit, of course, for the specific needs of the project. And we used that as the basis for the schedule. So we simply merged the sequence of execution for some typical stadium project that more or less fitted like 95% of the time to our new project, with the unique spatial arrangement or the spatial structure of our model in order to create a schedule. What we also had to do prior to that is also to populate the cost classification codes, because another important thing is we had to quantify the works for the project properly. So we had to simply, from the model, get the quantities and get description for all the works that have to be executed. For this specific project, we use combination of uniformat and master format cost classifications. Of course, the system is completely open and you can use any cost classification in the world. But in this case, we were able to do it. We were able to quickly populate the codes using data enrichment method. That means that we simply, again, go back to our knowledge base and say, okay, we have data enrichment tables that simply specify that, let's say, if the model element is slab, and it is a concrete slab, it is a structural slab, it should get the classification code for the structural slab from the uniformat, let's say. So we had predefined steps in order to quickly enrich the model. So we got the model with 300,000 elements that was classified in a matter of a few hours, or let's say half a day, in terms that we simply reused the knowledge that we had prior to this project, And we had the algorithms that simply recognize by the category of the elements and by the combination of specific properties to which category of class category it actually should go. So more or less with intelligent approach, we actually classified the model elements. We had the sequence of execution more or less prepared for this type of the project, with of course few tweaks, because every project is a bit specific. But in more cases, that's not more than like 10 to 15% in the worst case. And then we very quickly came to the basic schedule structure. That means that we knew exactly in which sequence we want to execute works. So in which sections, subsections, levels, and so on. We knew exactly what is technology of execution. So we simply knew the sequence of executed work. We knew exactly what are the quantities of the works that need to be executed by simply classifying the model elements, assigning it to the schedule, to the cost structure, and we built the schedule very quickly. Then came the, let's say, the most important part, and that is, one thing is to have the good schedule structure that has proper sequence, that has properly structured zones. Another thing is to have a good schedule in terms of proper durations, in terms of meeting the project deadlines, and in terms of using your resources in a proper way. So then what we did, we practically, after creating the schedule in a few very quick steps, when I say quick, I think a few days, of course, compared to what you would need to invest for a project of such scale in a traditional workflow. So when I say quick, I don't mean 2 minutes, of course. Then we got the initial schedule structure. So we automatically generated schedule structure that had more than 3,000 relations and tasks automatically, completely. So just imagine the time needed in order to generate such amount of tasks and relationships in any scheduling tools. And imagine then additional time needed to be invested in order to link those tasks and relationships to the model elements. Here we skip all of these steps because we use very intelligent approach where we simply specify the logic of the schedule zoning, the logic of the schedule, a sequence of work, and we created the schedule that is already 4D schedule connected to the model elements, and already 5D schedule because we already integrated cost classification, of course, at this point without the unit prices, so with the exact quantities that we had. And then, of course, what is also important thing that since our cost classification, our quantities are connected to the schedule, right away as the schedule was generated, we had what we call as the activity charts. So we could see exactly how many cubic meters of concrete need to be installed in which area of the building, in which period of time. And with this, of course, since this was completely initial schedule study, but the numbers were not really good. So we had huge oscillations. In 1 month, we execute like 20, 30 cubic meters of concrete per day in certain area. In some other months, 300, 500, and so on. So we simply saw that we need some optimization. How this was done, we specified the normatives. So for every group of work, we specified what is the capacity that is expected, of course, in coordination with general contractor. What are the expected capacities for a specific groups of works? What is the maximum capacity per day? And then the algorithm, again, based on these inputs from the professionals, simply adjusted durations in this schedule to fit these limitations. So, okay, if I could execute 500 cubic meters of concrete per day, and if I have a slab that is 1,500 cubic meters large, then the system will automatically say that we need 3 days completely to pour this slab, or in more realistic terms, we would probably subdivide it into 3 tacts or 3 subsections by along 1 day, so that we can execute it in a proper way. So we simply went through the fine tuning the relations between specific types of specific types of works. Then the next thing is, okay, we optimize resources, I mean the quantities of execution, but of course, then we came back to creating a few scenarios. Okay, this is the time needed with the limit, with the resources we have. If we go in this way, or if we go in a different way, should we go with a linear sequence, parallel sequence? Should we go in a radial way because this is a circular building, and so on? What is the most let's say optimal way to build this building for the period of time that is requested? Then we simply adopted a two main teams scheme, where we simply started in a radial way with two teams starting in the opposite directions to build the building properly. And of course, when we entered all the data, we got the schedule sequence, which simply gave us certain completion date with what we entered with a few scenarios. Of course, then we have the real limits, like simply the investor wanted it to be complete, let's say by the beginning of Expo in Belgrade in 2027. So they have even more harsh limitations to the completion date. Again, using the advantage of our softwares, we were able to simply move the finishing date prior to what was calculated, and we got calculations automatically what is the additional effort that we have to invest in the future in terms of additional resources, additional capacities for the quantities executed in order to meet the deadline that was set up by the investor. So with this, of course, we got very detailed calculations on what are requested capacities that we need to have on a construction site in which periods of time in order to achieve this goal. So from the beginning, practically this was a 6th or 7th day after we started the study, we had idea from the conceptual model with all of this additional data added. We had idea so we don't have detailed resources at this point, we don't have detailed unit prices and things like that, but we were able to have very detailed a plot of what are the expected quantities of execution for different types of works throughout a certain period of time. Of course, we tried to level this as much as possible, so to be efficient as possible. And with us, the general contractor simply had an idea what is needed to be done in order to achieve this goal. Then we switched to the line of balance view, which we also have in Bexel Manager, in order to optimize continuity of work. So we simply wanted to avoid, because again, we have very, very thin margins in this sense, simply with very tight schedule. So we had to know how to use the resources we have in a way that is not wasting the energy of the resource. So we had to make sure that every team is working constantly on the project without idling time, because that's the most efficient way, that's the fastest way, that's the best for the project, that's the best for the contractor. So we run few analysis, isolate, of course, organize the line of balance graphs by subcontractor, by phases, in order to see exactly and to try to keep first, to avoid possible problems and collisions in terms of, we didn't want to have the spatial conflicts. We wanted to avoid by any chance that we have two different teams or two different companies working in the same area at the same time. So that was the goal number one. And the second one is trying to achieve actually the continuity of work. So to reduce the idling time for any team on the project in order to make them the more efficient, and of course, and to simply finish the work on time. Of course, after that, that was more or less the end of the first week. After we had all of this analysis, we had to report this. So, having certain data in your software, in your expert environment is one thing. Another thing is when you have to present it to people that are simply not using some professional software and things like that. So you have to present the data in an understandable, appealing way so that they could understand and they could take decisions based on the data and calculations that you did. And for this, of course, the best way was to export data to the Power BI tool in this case, and to simply create all of this data that we see in the user interface of Bexel Manager, to present it in a proper way, and to map it on the model using Bexel Manager CDE, so Bexel CDE cloud-based solution, so that they could see exactly not only the numbers, let's say, of executed works or how the schedule stacks against the DCMA analysis, but also to see projection of that data on the model, so that they could actually understand that if we say that these are the quantities of concrete that have to be executed in the next 3 months, to see exactly to which elements these cubic meters of concrete will be mapped. So we simply created a range of reports, and as a first deliverable for this project, we had this video, which actually, so after 8 days of working, more or less, we had this video that from the concept design model was already prepared to a level that is very detailed 4D, 5D analysis. Of course, after we later started with the execution, we overlapped this data, we updated it to a certain level in order to simply get in more detail, since of course the project was further developed. We were able to simply show the zoning that we are proposing, to show the sequence of work, to show the quantities of execution that are planned for a certain period of time, so that people have the guidelines what they have to do. And of course, when we started building the project, simply people knew what are the next steps, what is expected from them. They have very clear idea, both in long term but also short term, what is expected from them to be done. They knew exactly what are the quantities and resources needed from their point to actually achieve the goals that are specified. So they have a very clear picture what I have to do. On the other hand, the investor had very clear idea what is expected and what are these interim goals that have to be achieved in order to actually get this to get to the goal at the end. So yeah, this is just another video just to show you. Also, this is like a realistic animation of executed works by using Bexel Manager and export to Unreal Engine, just to show. In this case, this was primarily used for the for presenting it properly, so that people could actually have a feeling how this is going to look like in reality on a construction level. So we had this part where we have a data to show, which is very important for understanding what is behind all of these animations. But we also have these nice animations that could give you the actual impression how the project is going to look like, and what is the sequence of execution for it to be built properly. So that is also something that was simply very important. So this is a public project, so the public needs to know how this is going to look like, how it's going to be achieved, and so on. So we had these requirements as well. And again, using the same integrated BIM approach, we were able to not only do this mathematical part of the thing, so to calculate everything properly, but also to actually then translate that data into a realistic video that could simply show the whole process that is planned. And again, this was achieved in a very, very short period of time. So we were able to simply achieve both things, to actually present how the whole project is going to look like and its execution, and also to make sure that behind all of this is very serious analysis, very firm data that guarantee that we're not going to have huge risks for this. And then after we started construction, actually the next challenge was, okay, we have idea how it should be built, but when you start the project, especially construction project, any construction project, it's a huge logistical and planning challenge. Why? Because if you think about the construction project, every construction project in the world is a prototype. Some people say that it's probably easier to just put the rover on the moon than to build a construction project. Why they say it? Because simply you have a lot of different stakeholders. Every building is specific, every market is specific, especially in this global world where you have contractors from one country, designers from another, project managers from third, investors for fourth country. They need to communicate, they need to coordinate, they need to come up with a proper way of building completely unique prototype building in its specific place. So the huge challenge was actually communication and administration. And this was achieved through our CDE module, which has this communication, a BCF communication way that simply is model based. That means that you can simply select the part of the model, attach documentation related to that part of the model. So to directly reflect documentation we're talking about, we're coordinating with the model elements in the model and simply exchange information through this integrated workflow. So this is something that was achieved in this way. This is just a short video showing how this looks like in an example of let's say look ahead planning and progress reporting. So we were able, since we have very detailed sequence of how the schedule should look like, we had idea simply to send people what is called a look ahead plan. So simply to present them what is exactly the part of the building that has to be built in the next week or 2 weeks or month, so that they have very clear expectations. Then they were able, again, to use the same system to simply report back what was actually achieved by directly selecting the model elements. So we were not, we simply don't have the need, as in a standard workflow, to simply believe you on your word that this is 20% complete or 30% complete. No, you simply can relate to the model and simply select the elements that are completed. Then we can come up with the point cloud. We can overlap what you actually reported as completed. You can attach the pictures for the works that were completed. Everybody could simply go check it. The supervisors could confirm this, and then we can populate the progress into Bexel Manager and run the calculations and see what is the earned value, what is the planned versus actual analysis, so we can have key project indicators in real time, and we can validate all the input data very simply. And in order to achieve this properly, this progress workflow in the first place, we come up with another very important concept. And that is that we simply understood that the main challenge in reporting the progress, not just in this project, in every project in the world, is that simply the schedules that you have, even the best schedules in the world, are more or less strategic project plans. So what you do, you simply on a strategic level, when you start construction, when you plan your construction, on a strategic level, you specify or outline how the project is going to be built. On the other hand, the people working on site, they actually need something that we like to call a tactical project plan. That means that you need to be able to actually look in the same schedule in a different way. That means that you are actually, your request as a site manager are to have much more detailed schedule, to have much more flexibility in order to see what are the amounts of work that you have to execute and what is the information that you have to report back. So we focused, okay, our strategic project planning was pretty much covered with the workflows that we had, because we had a very, very clear idea how to integrate 5D into project, how to integrate 4D into project, how to build a detailed schedule in an automated and a good way, how to optimize the schedules. But we felt that we have a gap between this strategic project planning and the needs of construction site. So what we did, we focused on a tactical project planning module, so within CDE. So we built a module that will allow people on site to take the tasks from the strategic project plan, from the Gantt chart, and to subdivide it into the structure that reflects more in detail their sequence of work, and to allow them to work let's say, focused on this microcosm of the work that they have to execute. I mean, one of the examples, let's say. So if we have to execute on the stadium this concrete piles, and if I'm the subcontractor who's focused on certain area for the concrete piles where I have to execute 20 concrete piles in 5 days, let's say, honestly, I would like to have ability to schedule every one of them, because every one of them is 15, 20,000 US dollars. It requests a lot of materials, or a lot of resources. So I want to know the exact sequence of execution. Of course, we cannot expect that on the strategic level, on the master schedule, we have such a detail. So what we could do, we could allow this site contractor, site manager, to simply takes this this piece of schedule and to break it down into smaller subtasks and to organize it in a way that fits his own needs. So what is the idea? The idea is simply that if I know that, okay, this is the tasks, scheduled tasks that I have to execute in the next, let's say, 1 month, I can simply select this group of elements in this specific case, and I can subdivide it to the smaller activities and specify the sequence between them. So what I could do, I could simply take these 9 or 8 piles and subdivide it for every pile. So just use the property pile mark, which I have on the model, and say, okay, this is the sequence of execution for every pile. And within every of these activity, I have the sub-activities of my own that I manage that are simply not managed on the higher level. So this is the general idea behind this module. So I can then simply go and organize my sequence in a much more detailed level than it was in the strategic plan. I could then simply relate, again, we still have the BIM model. I can select these groups and subgroups of the elements, and I can relate them to the communication, to the issues related to them, to the clashes related to these elements, to the documentations related for these elements execution, and I'm gonna also be able to report my progress back. So what is the logic behind this? The logic is that you take this task schedule from the strategic or the main master schedule, and you create what we call a canvas. So the canvas is actually my mini schedule, let's say, where I have ability to simply break this task into smaller zones, so to add additional level of subzones. And for this, I could refer to any element property that I have in the model. So in this case, this person was able to subdivide this 9 task sequence for every task to actually specify if it's going to go, left to right, go in circles. So whatever is the idea behind him, whatever is the best utilization of the equipment this person has in order to execute his work. And I also have ability to simply then specify the detailed sequence for this. And I can also organize my teams, my activities, my resources in a proper way. And of course, the best way is after I organize this and after I micromanage these 2 or 3 teams that are on the construction site by giving them simply more detailed tasks. So let's say if I have 2 drilling machines and I have to go to complete this area in a week, I could simply assign them specific piles that need to be driven, to specify the sequence, to specify the hours needed for work, instead of just saying them, okay, there is a task, subzone 4C in a zone 4 that needs to be executed. You have 1 week, you have two pile drivers, just go ahead, because that's simply not detailed enough for the needs of construction site. What is also a great thing is that not only that they could simply see or have a look ahead in what they need to do, they will also be able to report the progress back in a much easier way. So at the end of every day, so first they're going to have very detailed schedule for their working day. So they're going to know for which pile they have to do which activity, for instance, and then they're going to be able to simply, very often, very easily report if this micro task is completed. It is much easier to simply say, okay, today we completed file 1007 and 1008. And we completed the drilling, and we also completed the concrete pouring for 1006. Then to simply, at the end of the week, say the area 4C is completed 25% or 30%, because that number doesn't mean much to anybody who's looking on a big picture. On the other hand, the system is doing this. So you're reporting in your canvas, in your micro tasks, but the system is converting these reports into the progress on a master level. So if I'm an investor, I really don't want to know exactly what is the percentage of completion of drilling on the pile 10012, but I want to know the percentages. But on the other hand, if you actually have your detailed progress reporting on the micro level, then I'm going to be sure that the reports I see on a strategic level are reflecting the real data on a construction site. What is also great thing, when you have such a system integrated in integrated BIM solution with the BCF communication, you have ability to simply confirm or reject certain progress. So I, as a subcontractor, I'm going to simply add the progress data. I can submit this data to the supervisor. Supervisor could simply relate to the model, to the actual site footages and videos, to overlap the point clouds, and to confirm if this is right. And on the other hand, it could confirm it in a very short period of time, and I could get my monthly certificates again in much shorter period of time. So everybody is benefiting in this. We're cutting the times needed for reporting back the data. We have reliable data, and we are cutting the times needed to actually confirm the monthly certificates and to improve the cash flow of the subcontractors in this case. And not only this, another advantage is that this is maybe even more intuitive example. So let's imagine that we have a schedule, that we have, let's say, finishing works on a high-rise building. And of course, in the schedule, we're going to probably have hour 1, 15th floor, painting the walls. That's going to be the strategic schedule task. You're not going to go into details there. But if you're working on a construction site, you're going to definitely have a guys sent into apartment 1, apartment 2, apartment 3. So that's the way you're going to work, because that's the easiest way. You're not going to just say, okay, just go from left to right, and then when you finish this wall, just jump to the next apartment and continue the same wall on that side. You're not going to do that. You're going to simply have your teams put in a different apartments. So this system will allow the subcontractor or site manager to simply subdivide this simple task of painting the walls on a 15th floor into specific apartments. Why is that great? Because if our relationship was finish, start, painting the walls, and I don't know, installing the doors, we're going to now have simply, if that was finish, start, that means I had to wait until all the walls are painted on 15th floor and then start with installing the walls. In this case, the two teams that are doing this work, that are finish, start, connected, would simply go and in our separate canvas subdivide these tasks into specific areas, in this case apartments, and simply say, okay, as soon as I complete, let's say, the apartment number 1, I'm going to move my team to the apartment number 2, and you can jump in with the doors in apartment number 1. And not only that, I'm going to simply go and say, okay, this apartment is bigger, so it's going to take me 1.5 days. This one is smaller, it's going to take me half day. And maybe you can install all the doors in 3 hours. So we're going to just see that it would be the most beneficial for you to come in Wednesday, let's say, to start installing the days in the first apartment, because my works are much slower, and then you're going to catch me up, let's say, by the end of the week, and you're not going to have you're wasting your time by simply completing the apartment that we completed yesterday, and then have to wait until I complete the next apartment. So I have a very clear idea on a micro level what is coordination between teams. So not only that, the great thing is, because again, these subtasks are connected to the schedule, connected to the budget, connected to documentation that we have in CD. That means that I could simply, if I have to work in apartment number 15 on the 15th floor, I can select the subtasks for that department, and I can isolate all the issues related to that department. I can isolate all the clashes related to that department so that I know if there are certain problems that are not solved. So that is completely realistic scenario. And I could directly see, filter out the documentation, the design documentation that is related to that group of works. So everything is there. So we like to call it the work front management. So I know exactly first what is expected from me in the next 2 or 3 weeks. So I have short-term planning, very detailed short-term planning. I can coordinate with other people that are dependent on my work in a much better way, because it's one thing to coordinate if I know that I'm going to work in apartment 1, and it's another one if I know that I have 2 weeks to complete the whole floor, because I can overlap in a much more sensible way with the other people and coordinate and lose less time if I have ability to simply micromanage these works. And it's a huge thing if I could simply connect my model elements so that I know exactly when I select a certain group of work that I have to execute, and to see what are the issues with these elements, what are the possible challenges in terms of clash detection, and what is the documentation need. And of course, you have ability after you do this to see also the possible problems on site, to attach photos of what is executed. So in this specific example, let's say you have to execute this during the next week, this area of the files, and then you see certain construction materials put there. So you can simply raise a question, you can simply create a new issue and say, okay, I cannot start my work during next week because I cannot access the construction site properly, and things like that. So you can, or simply you're gonna, there was a problem with this area. We found some water, or there's some geological anomaly. We created an issue. We selected the future possible affected foundations. When I have to do these foundations, I'm going to simply select them from the schedule. I'm going to filter out the issues, the active issues, and see if those issues were solved or not. If they're not solved, I'm going to reschedule my work, and I'm going to probably jump to another area. So in every moment, I know exactly what is expected from me and what are the conditions on site. So as I said, the idea is, the final goal is that you simply have for every task and subtask, let's say, green light or red light. So you're going to simply know, you're going to simply have a color. Okay, this task is ready for execution. There are no active issues. There are no missing documentation that is not confirmed. So I know exactly what is, there are no pending changes, and so on. If there are certain clashes, I'm going to know if those clashes are solved, if they are high priority, a low priority, maybe they're not solved, but somebody simply gave me the written solution, what I have to do in order to avoid problems in the future. So simply with the selecting elements, I could see exactly what is the work front status at the moment. I could very quickly relate from the selected elements from Gantt chart to documentation. So I can very easily navigate the documentation and open it, because we have this unique approach to simply relate documentation with the to relate the documentation with model elements. So I have ways to simply control what I have to execute very, very easily and in a very simple way. Okay, so we passed the 45 minutes mark, so I would just like to confirm if we can continue a little bit to the practical explanation, or you have a hard stop. Just Rolandas, if you can confirm me.
Yeah, I think we can move.
Okay, so I'm gonna try. I'm gonna try to a little bit squeeze this, just to explain some things in live examples as well. So the whole idea is, and what the focus is, and what is the main purpose of this integrated BIM, is to have reliable information. So everything that you see, it's simply possible just because we have reliable information in the model. Why? Because the only sure thing on the project is that the project is going to be changed. So when somebody tells you that he simply calculated the quantities to the very lowest detail level possible needed. That's fine. If you did it manually, how valid that is going to be in 3 months? Probably not much, because simply you're going to get the updates. You're not going to have time to do this if the process is not automated. So one of the core processes that need to be properly managed is 5D management, or the cost integration. And how our system works is that simply you have a cost classification that looks like this. So it's a simple cost classification, looks like any other cost classification in the world. You would have this in Excel as well. So you have groups of works, subgroups of works, cost items. Those cost items will have the code that identifies them. They will have the name or description. They will have the unit cost. They will have the quantity types and quantities. So this is what you have. So, and this is completely in line with how the Bexel is actually managing this same approach. The only difference is that with Bexel Manager, when you integrate this cost classification inside the Bexel Manager, you specify what we call element query. So element query is a filter or a rule that will say these groups of elements should be used for calculation of this specific cost item. So it could be as simple as we're going to code the model elements that are foundations, we're going to code model elements that are windows, and so on. And then the rule is simple. If this is the code, just find the element with the same code and use that one for the calculation. Or it could be descriptive, like you say, okay, there in this specific cost item, I want to include all the elements that are structural foundation and that have a concrete as their material, and that have, let's say, concrete type MB30, for instance. So I could combine certain properties of the model elements. So the thing is simple. You specify this link, and then whatever happens with the model, if we delete some elements, if we add new elements, if we change the volume and shape of those elements, the system will automatically reflect the change in the quantities and reflect the changes in the budget as well. Not only that, after I establish such a cost database, I have ability to specify resources if I'm managing resources. So I could have very detailed, if I'm a contractor, I could have a very detailed list of my resources. I could track the unit cost of the resources, and then I could simply map for every cost item what are the resources needed for the execution of one unit of that specific cost item. So I can very quickly specify my normatives, and simply my cost calculation will be based on the actual quantities from the digital copy of the building that is constantly updated, whatever changes to the project. And my prices are going to be indexed in the resources, in the actual price of the resources. And of course, this is the most practical and the most accurate way, especially in the industry like construction, where the profit margins are very low in this industry. So we have to minimize the risks in every possible corner in order to simply survive. So in order to do this, we have to be very careful with the calculations in the first place, because there were companies that simply bankrupted because they simply didn't calculate the quantities properly and prices properly. It happened. You simply sign the contract where you cannot claim something. You trust the tender package quantities, and then you are in the problem. So because of this, investment in integrated BIM is the best way to simply lower these risks to the maximum possible level. And that's why I'm explaining you the technology behind this, and that is that you simply have your cost classification mapped to the model elements. Whatever happens to the model elements, whenever they change, it's going to be reflected in the quantities, it's going to be reflected in the more resources needed, it's going to be reflected in the unit price, and you're going to have very, let's say, robust data layer that supports your product. So the first part is that you simply specify this query or a filter that will take the elements that fit the description needed for this specific cost item. The second part is quantity formula. That means that your quantities are going to be dependent on the properties of these elements. So if I have to simply calculate the area of this wall, that means that I'm going to say, okay, there's a cost item, Alocobond facade, let's say. So find all the elements that have the uniformat code of a specific code, so B2010-100, and then take the area of this element. So whatever happens tomorrow, whatever changes in the project, this area is going to change as well, and my prices are going to be adjusted, and my resources are going to be adjusted. So how the system works, we simply specify cost classification. That could be done also in Excel and then imported in Bexel Manager. So there is no need to specifically, so let me just call it demo, to specifically work just in Bexel Manager. You can simply export this cost classification in Excel. Let me just bring it from another screen. And in Excel, specify all the details of your cost classification, or vice versa. You use some cost classification, you probably have it in some Excel format. You simply reformat that cost classification into machine-readable format that Bexel could import it once into Bexel Manager, and then you have ability to use it in the future on your project. So simple as that. Once you specify your cost classification, of course, you can reuse it in every future project without more or less any changes, probably with some updates, because you're going to probably get from time to time new cost items, but that's like 2% of update with every new project. After that, you do what we call auto assigning cost item to the model. That means that the system goes through the rules that you set up, finds the elements, and calculates the budget or the estimate. So once you do that, you simply know exactly what are the quantities. You simply have ability to say, okay, let me just go and find group of works or subgroup of works. So let's say special foundations, standard foundations, select elements, isolate them, and you know exactly in every moment what this number is, that it is supported by calculation of volume and reinforcement density, or whatever is the property used for that specific group of elements. Or vice versa, if I want to know for some specific, let me just show all, for some specific piece of building, to know exactly the price and quantities. So if I select this and say filter by element selection, I'm going to simply know exactly what is the area of that specific piece, how it was calculated, what is the unit price, what is the overall price. So, and of course, if I go and select additional elements, you're going to see how the quantities are updated. So I have very clear idea what are my costs, what are my risks. The best thing of all is that you're not limited to Bexel Manager as a desktop application. You have ability to publish this data to the cloud. So simply you can go and publish your cost classification to the cloud and have all of this data as well available in the cloud. So you have ability to simply go and to give this data to people on site. So what I can do, I can do it like this, and I can say, okay, I'm going to select, let's say, exterior walls. The system is going to show me which are the exterior walls. I could see the price of them, you know, and I can go to specific, let's say, louver screens and fencing. It's going to just isolate those elements. And again, what else I can do? I can again do the same thing as in Bexel Manager. So I can select the elements that have to be executed and see the quantities. Filter by selected elements, and I can see exactly the 4 cost items that are relevant for these 3 elements. What are the quantities? What are the prices? What are the units needed? And probably the best and the most important thing is that I can also, from the schedule, go and actually find, let's say, pile foundations and select elements from the schedule, isolate them, and see them again as a model. So I can see what is expected from me to be done during next week. I can go and switch back to the cost estimate and see exactly what are the quantities expected from it to be built and what are the cost items involved. I can go to the BCF manager, filter by selected elements, and then filter out all the issues related to those specific elements. And I can also navigate very easily to the documentation relevant for that specific group of elements. So if I have to build this part of the project, I'm going to simply, just to see, I'm going to simply open this attached document, this attached design documentation, and see exactly what has to be done next week. So simple as that. I can very easily navigate and see all groups of works. And why is this possible? Just because we were able to simply relate this cost data, relate the schedule data to the model, relate the issues and the documentation and everything related to the project to the model elements. And through the BIM model elements, we are able to simply then relate all of these different databases and to have a clear picture what is relevant for the construction process.